Okay, so essentially what we're doing now is using the shortcut to decrease the process in finding certain things that we need, whether we're looking for the velocity at a given value so we can take the derivative, or we want to find an equation of a line that is tangent to the given curve at x equals -1. So now, before, the process was longer. Now we want to find an equation of a line that is tangent to the graph, and we're going to use this function at x equals -1. Okay, so what are all the things that we need when we're finding an equation of a line that's tangent to the curve? We need a point and slope. Okay, so we have the x value. How do I find the y value? Plug what in? Plug in -1. Okay, so y is equal to 2 times the cubed root of -1. What's cube root of -1? Oh no. Okay. Do over. What's the cube root of -1? Okay. Sweating. Jeez. So y is equal to -2. That was kind of scary.
Wait, what? Oh.
All right. So we have the point, y'all, at -1, -2. Are we good?
Yes.
Okay. Remember, folks, you could take the 85th root of -1. It's -1. I mean, that's what's so great about 1. You can take any root, right? And it's quick. So a lot of times these questions will be asked with 1 and -1 because it's fast. Okay, but you got to get the right derivative, so that's the key. So now that's what we need. We need to find the slope, which is the derivative. But now we don't have to go, oh, fine, the limit as h approaches 0 of f. We just have to use a shortcut. So the first thing we need to do is rewrite this in friendly form. So we have y is equal to 2x to the 1/3 power. Right? Okay, this is where you're going to see me use y prime, so I'm going to be very careful and make my prime very prominent. Y prime is equal to 2/3 x to the -2/3. Is that correct? Everybody okay? So when I simplify this, this is the slope. It's 2 over 3x to the 2/3 power. And we want to evaluate this where x is equal to -1. This is our slope. Okay, so this is actually going to take us a little bit back to Algebra 2. Okay? Yes. Oh, stop. 2 over 3 times -1 to the 2/3 power. Let's talk about this for just a second. We could do this one of two ways. We could say, all right, let's take the cubed root of -1, which is what? And square it, which gives us 1. And then we multiply by 3, which gives us 3. So my answer is 2/3. Or, wouldn't this also work if I took -1 and squared it? Gives me 1. Take the cube root, which is still 1, right? It still works. Now, this is where you would have to make a choice, because what if your x value was 27? Just hear me out. If I took 27 to the 2/3, I don't have a calculator. Are you going to square it first or take the cube root first? Definitely. So you have to make a decision. So it doesn't matter which way you do it. When I taught Algebra 2, I always taught the root first because typically you're given higher numbers. If you have 1, it doesn't matter. I mean, if you square 1, it's still 1, right? So it's not a big deal. Is everybody good with this? Yep. All right, so now we have our slope. Do we have everything that we need to write the equation of the line that's tangent to the curve at x equals -1? Yes, okay. So, using y minus y sub 1 is equal to m times x minus x sub 1, let's fill in the blanks. Y minus what? Ooh, it becomes plus 2 is equal to 2/3 times x plus 1. Do I have to distribute?
No.
No. I think there was a homework problem maybe where I remember looking at it and they wrote it in slope intercept, but I think the answer key gave it in y equals mx plus b. It's fine. I mean, if you want to check to make sure yours is correct, go ahead, but leave it like this. It's easier. Okay? Questions? Okay, so now, much easier, right? Less work. Okay, you have graduated to the shortcut. Awesome. All right. So there are specific steps to find points where the graph has a horizontal tangent line. So let's talk about this. First of all, what does it mean if I want you to find the points? Can I just say x equals? What's a point? XY. So this right here means you have to give me a coordinate. Or coordinates, plural. It just depends. Now remember what I said. In calculus, they don't always say, oh, do me a favor and find the slope. Find the slope for me. They're going to say, find the average velocity. It's all about vocabulary, and there's lots of different ways that you can say things. So in this case here, it says, we want to find the points. So we want the coordinate or coordinates where a graph has a horizontal tangent line. Horizontal tangent line. We've been finding, say what? Yes, this is where our slope is 0. So it's saying, tell me the points where this curve has a slope or slopes of 0. Could be multiple places, right? So here, this means m is equal to 0. What is m? What's another way of saying m, though? F prime, our derivative. Okay, it could be x, it could be t, it could be m. I'm just writing f prime of x. Okay, everybody good? All right, so this is what they're saying. The first thing we want to do is find the derivative. This is step number 1. Step number 2, we're going to set the derivative equal to 0. This means your slope is equal to 0. You will solve for x is equal to a. Okay, what? You're taking the derivative, setting the derivative equal to 0. A lot of times it's going to be a polynomial of some kind, maybe a rational function. We'll get to that. But you want to solve for the values of x, or maybe 1, in that function. Okay, that's set equal to 0. Then you will substitute. This is the key thing right here, guys. You will substitute those values into the original function to find the y value. Okay, I used a different color because the most common mistake made is that people will then take that x value and put it back in the derivative. We don't want that. We want the points on the original graph where the tangent line is horizontal. Okay? So you have to use the original function. All right, well, how does this work? It says, at what points, if any? Ooh. Does the graph have a horizontal tangent line? So we're going to follow the steps, but I want to ask you really quick, what does that mean, if any? What does that mean? Oh, you might not have any. Man, did they really have to throw that in there? All I'm going to do is solve. Yes. You have to be aware. But is that like a hint? Like, maybe there aren't any? No. You still have to do the work. Okay? So, you just need to be aware that sometimes you might not have a solution. How do you know? Your proof is in the math. You have to do the math. Okay? So here we go. Our first step is to find the derivative. So I'm going to label these. Step number 1, we want to find the derivative. F prime of x. Using the shortcut. Let's go. What's the derivative? 3x squared minus 2x. Check. Derivative. Okay? Okay? Step number 2, we're going to take the derivative, which is another way for us to find the slope, and we're saying that the slope is 0. Remember that word is represents an equal sign. So 3x squared minus 2x minus 1 is 0. It's kind of a question. All right, this is a polynomial, so that means we need to factor. You guys all know different methods to factor. I'm old school. I use slide and divide. Some of you don't even know what that is. Some of you just do it if you had Mr. Conlon. Box method, whatever you use. So if you don't use slide and divide, you can ignore how I do it and just factor as long as we get the same ones. So x minus 3, x plus 1, divide by 3, divide by 3. This is x minus 1 and 3x plus 1. Okay, do you guys remember how to factor? Yes. I'm just asking, because there's some giggling, and I'm not really sure what was going on. Okay, does everybody see how we got these are just factors. So I need my x coordinates. So we're saying that x is equal to 1 and negative 1/3. Okay, so this was actually step 3. These are my x values. Question. Am I done?
No.
Why?
don't have your x and
Y value.
That's right. I do not have my y values, so I need to plug these back into the original. So my original is here, so let's do the easy one. So this is step number 4. We want to evaluate f of 1. This is 1 cubed minus 1 squared minus 1 plus 1. What is this? 1 minus 1, 0. Minus 1, negative 1, plus 1, 0. Okay, so the first point on this curve where I have a horizontal tangent line occurs at 1, 0. Okay, I picked the easy one first because this is a non-calculator question. We need to evaluate f of negative 1/3. So basically I'm plugging negative 1/3 in for all my x's here. So we've got negative 1/3 cubed minus negative 1/3 squared plus 1/3 plus 1. Everybody good? So all I did was plug in. Negative 1/3 cubed is what? Negative 1 over 27. This becomes minus 1 over 9 plus 1 over 3 plus 1. I need a common denominator. Yep. Negative 1 over 27 minus 3 over 27 plus 9 over 27? Yes? Plus 27 over 27? So negative 1 minus 3 is negative 4, plus 9 is 5, plus 27 is 32 over 27. So then my other point is at negative, 1/3, 32 27ths. These are my 2 points. Questions?
So these two, this point is the derivative?
There's a horizontal tangent line, slope of 0. So this one and this one.
So what would that be called? Is that A? If it's the horizontal asymptote.
No asymptote. Horizontal tangent line.
Oh,
So that means I would have a
Yeah.
curve, whatever the curve is, if I sketched it like this, let's say, horizontal tangent line like this. So that would be at like 1, 0.
But what's the point? Is it A? The coordinate, what's the...
This is A, f of A.
Okay.
Any other questions? All right, so in this class, as I told you before, the highest derivative that we're going to use in terms of functionality is the second derivative. If we ask you to take any other derivative, it is more so for practice than anything else. There are other functions for higher derivatives, but it goes beyond the scope of this class. So if we're talking about higher derivatives, okay, you'll be finding f prime of x and f double prime of x, and you would just continue to repeat the process. So if I asked you to find the third derivative, you would find the first derivative, indicated by all this notation here. Okay, then you would turn around and find the second derivative. So this is the notation for the second derivative. And then you would find the third derivative, okay, which we're going to do an example. Okay, all of these others, like I said, are just for practice, though. These two actually have purpose for us, velocity, acceleration. Okay, so I'm skipping A because you should be able to take the second derivative. I'm going to go to B. And here's the notation. And the reason why it looks like this is because if you had the first derivative and then you're taking the second derivative, what's d times d? It's d squared, right? Since the d is already taken care of, you multiply the x's in the bottom. So in this case, you would get d squared dx squared, like that. And then you would multiply again. You don't really need to know where the notation comes from. It's just how it's written. So what we want to do first is rewrite this in user-friendly form. So what is that? X to the negative first power. So when we take the first derivative, d dx, this is equal to negative x to the negative second. Okay, that's our first derivative. When I take the second derivative, this becomes 2x to the negative third. When I take the third derivative, This is negative 6 x to the negative 4th power, correct? And we want to evaluate when x is 1. Okay, see what I said? They like to ask 1 a lot because it's easy. Because I'm evaluating 1, do I need to rewrite this as negative 6 over x to the 4th power? All right, what's 1 to the 4th power or 1 to the negative 4th power? Either way, it's still going to be 1. So my answer is negative 6. Okay, does anyone have any questions on higher derivatives before we go to the last page?